Welcome to our solution series. Today we want to look at May-June 2023 paper 4 variant 2. In this structured question, I want to look at 4 key topics: gravitational field, ideal gas, oscillation and capacitance. It's quite important that you know how to go about it. If you are struggling with how to answer questions under these 4 topics, I want you to be very attentive as I take you through the questions under this topic in this paper. This is May-June 2023 paper 4 variant 2. Let's start with the first question. Question 1. State Newton's law of gravitation. Newton's law of gravitation states that the force between 2 point masses is proportional to the product of the masses and inversely proportional to the square of the distance between them. B. A satellite is in a circular orbit around a planet. The radius of the orbit is r and the period of the orbit is t. The planet is a uniform sphere. Use Newton's law of gravitation to show that r and t are related. 4 pi squared r cubed equal to gmt squared, where m is the mass of the planet and g is the gravitational constant. In this question, for you to answer that, you have to compare from your definition that gravitational force is equal to centripetal force, and from our definition, gravitational force is gmm over r squared will be equal to m omega squared r. So we will change omega to 2 pi over t. This will give us g mm over r squared equal to m 2 pi over t squared r. Let's take the m's out. So this will give us gm over r squared equal to 4 pi squared r over t squared. We rearrange it. This will give us gm t squared equal to 4 pi squared r cubed, which is what we are asked to show. The next question. The Earth may be considered to be a uniform sphere of mass 5.98 times 10 raised to the power of 4 kg and radius 6.37 times 10 raised to the power of 6 meter. A geostationary satellite is in orbit around the Earth. Use the expression in B to determine the height of the satellite above the Earth's surface. In this question, it's important for you to know that a geostationary satellite means that the satellites will move with a period of 24 hours, which is 24 times 60 minutes times 60 seconds. That will be the time we are going to use, and this should be 86,400 seconds. Now we will find r using the equation that we got. We had gmt squared equal to 4 pi squared r cubed. R will give us gmt squared over 4 pi squared cube roots. Let's put the values. The g constant is given as 6.67 times 10 raised to the power of minus 11 times the mass 5.98 times 10 raised to the power of 24 times our period 86,400 all squared divided by 4 pi squared. Remember, it is cube root, and r will give us 4.23 times 10 raised to the power of 7. The question says we should find the height of the satellite above the Earth. height will be r minus the radius of the eighth. This will give us 4.23 times 10 raised to the power of 7 minus the radius of the eighth, 6.37 times 10 raised to the power of 6. And the answer will give us 3.6 times 10 raised to the power of 7 meters. So h is 3.6 times 10 raised to the power of 7. Let's go to the next question. Another satellite is in a circular orbit around the Earth with the same orbital radius and period as the satellite in C. Calculate the angular speed of the satellite in this orbit. Give a unit with your answer. Angular speed is simply 2 pi over t. They said it has the same period as that of the satellite, meaning geostationary period 24 hours, 2 pi divided by 86,400 seconds. This will give us 7.3 times 10 raised to the power of minus 5 rad per second. You must ensure you put your unit correctly. Despite having the same orbital period, the orbit of this satellite is not geostationary. Suggest two ways in which the orbit of this satellite could be different from the orbit of the satellite in C. For it to be the same, it means that it's supposed to be located at least above the equator. So the satellite is not located above the equator. We can also say that the satellite is not moving from west to east. Originally, the one of the edge will move from west to east, but this is not moving. That differentiates it from the other one. The next question is ideal gas. We are done with the gravitational field. Now, ideal gas. State what is meant by an ideal gas. An ideal gas is a gas that obeys general gas law perfectly. PV equal to nRT, in which R is the molar constant, T is the absolute temperature, P pressure, V volume, and N is the number of mole. State the temperature in degrees Celsius of an absolute zero. For an absolute zero, that is 0 degree Kelvin, and 0 degree Kelvin is the same thing as minus 273.15 degrees Celsius. A sealed vessel contains a mass of 0.0424 kg of an ideal gas at 227 degrees Celsius. The pressure of the gas is 1.37 times 10 raised to the power of 5 Pascal, and the volume of the gas is 0.640 meter cube. Calculate the number of molecules of the gas in the vessel. Here we are asked to find the number of molecules. We can use two kinds of formula. Either we use nkt equal to pv, or we use nrt equal to pv. Later we put n to be n over na, meaning n will be equal to na. Anyone that resonates well with you, you can use it. Now let me pick the one like n equal to pv over rt. This will give us 1.37 times 10 raised to the power of 5 times volume 0.640 divided by molar constant, that is 8.31, times absolute temperature. We are going to add 273.15 to it. This is what you will do, and once you do that, you'll now be able to find it. So n will give us here 21, and remember that our n equal to na, that is 21 times 6.02 times 10 raised to the power of 23. This will give us 1.27 times 10 raised to the power of 25. Since it is number of molecules, it has no units. Now, the mass of one molecule of the gas, the total mass is 0.0424 kilogram. One molecule will be equal to 0.0424 divided by the total number of molecule, which is 1.27 times 10 raised to the power of 25. This will give us 3.3 times 10 raised to the power of minus 27. Okay, that is sorted. The root mean square speed of the molecules of the gas. In this one, remember we have a PV equal to 1 over 3 nm mean square speed. We are asked to find the root mean square. Root mean square is simply square root of mean square speed. For us to find this, we will first find and now put it together. This will give us root mean square equal to 3 PV over nm. This gives us 3 times 1.37 times 10 raised to the power of 5 that they gave us times 0.640 we are divided by the total mass that was given to us 0.0424. This will give us 6.204 times 10 raised to the power of 6 meters squared per second squared. We say root mean square, which is equivalent to V, equal to square root of mean square speed. This is square root of 6.204 times 10 raised to the power of 6. This gives us 2490 meter per second. This is what you will write here. Alright, let's get to the next question. The gas in B is now cooled gradually to absolute zero. On figure 2.1, sketch the variation with thermodynamic temperature T of the root mean square speed of the molecule of the gas. Root mean square speed and absolute temperature. We saw it that root mean square speed is equal to square root of mean square speed. And basically, if we say nkt equal to half or 3 over 2 m mean square speed, we use this for kinetic energy, and this is where we have the relationship between mean square speed and absolute temperature. So temperature is proportional to mean square speed. If mean square speed is square root, it means that root mean square will be proportional to square root of the temperature. They are proportional, but this is square root. Due to that, they will start from 0. As the speed increases, the temperature will increase. However, the temperature will increase in this manner. Temperature will increase in this manner. Take note of that. It's not going to be linear because it's root mean square. We are done with ideal gas question. If you have any question, drop it in the comment section. I will respond to it during my time of solving. The oscillation question. A small steel sphere is oscillating vertically on the end of a spring as shown. The velocity v of the sphere varies with displacement x from its equilibrium position according to v equal to plus or minus 9.7 square root of 11.6 minus x squared. Calculate the frequency of the oscillation. omega equal to 2 pi f. From this expression, we can compare it with v equal to omega into x naught squared minus x squared. So 9.7 equal to 2 pi f. F equal to 9.7 divided by 2 pi, and this gives us 1.54. Show that the amplitude of the oscillation is 3.4 centimeter. Looking at the expression that I gave you here, I naught squared equal to 11.6. I naught will be square root of 11.6. This is 3.4 cm. Calculate the maximum acceleration of the sphere. Maximum acceleration will be equal to omega squared x naught. That will give us 9.7 all squared times 3.4 times 10 to the power minus 2. You have to change it to meter. This gives us 3.2 meter per second squared. B. On figure 4.2, sketch the variation with x of the acceleration of the sphere. We got acceleration as 3.2 and we got the amplitude as 3.4. Those are the things we will use. Remember that acceleration is proportional to displacement in opposite direction. So if this is 3, is 3.2, we would use that. So I naught here will be here and will be here through 3.2 is 3.4. We would draw a straight line that will pass through the origin. This is how it will look like. Describe without calculation the interchange between the potential energy and the kinetic energy of the oscillation. At the equilibrium position, the potential energy will be 0, while the kinetic energy will be maximum, since the speed will be maximum at this point. Now, at the displacement, the maximum displacement, the kinetic energy transferred will be 0, and while the potential energy will become maximum. So there is an interchange where kinetic energy is 0, potential energy is maximum. That is how it displays. So there is opposite interchange between the two of them. We come to the end of this solving. We have answered question under capacitance, ideal gas, oscillation, and gravitational field. Pick another paper, check how you can answer these questions under these topics. This was May-June 2023, paper 4 variance 2. See you in our next video.